So the next type of problem that we're going to deal with here as we go forward is when we're talking about questions or contextual problems which deal with a combination of two variables. Okay, so we could have a combination of two variables. What that means is we usually have some sort of total at the end, and we use two different variables to come up with that total. Now, this could be, and this would probably be, I would say, the most common, and that includes on your assignment. This could be adding two values together, or now a little bit less common, could be subtracting a value from the original number. Okay, so it could be subtracting a value from an original number. So we could have two numbers being added together, and in that case, then those two numbers would be the our two variables usually, or we could have a starting value and then we subtract something else. Okay, now that starting value could be a variable as well, and so we could have two different ones, and we're going to take a look at an example of that as well. So let's look at a couple of examples. A grade 3 class has a combination of male and female students, or boys and girls. There are 23 students in the class. 23 is our total, and we have two different types of students that we're breaking into. Okay, and so what those types of students are going to be is those are going to be our variables. X is going to be the number of male students, and Y is going to be the number of female students in class. Now, I did X as male and Y as female, but that is not to say that you couldn't have switched those around. Okay, I think in a previous example, I did Y as X as females and Y as males. That is completely up to you. You can do kind of whatever you like on that. But it's the important part is that we are defining what our variables are. So this is part of our defining our variables. Now we know if we're given a value for X, we know that X is the number of male students in class. And not only do we know that, but anybody who goes through and reads these notes and takes a look at this question, they'll say, oh yeah, X is definitely the number of male students. So if we come up with a solution, we know that the X part of our solution is the number of males, and the Y is the number of females in our class or in the class. Now, when we put this together, we want to create an equation. And that equation that we're going to create is going to deal with X and Y. Now we're told that it has a combination of male and female, so we can assume based on what we see is that X plus Y is equal to 23. So X plus Y is equal to 23. Now that is our equation. From that equation, we can come up with all sorts of solutions. Okay? And the solutions, well, they're not endless because, well, we're not going to do negatives or nor are we going to do decimals. Okay? And we could kind of say that as well. But we're going to come up with some solutions. And we could say that X, let's say X equals 20. Well, then Y has to equal 3. Right? There's a solution to this question here. If there are 20 male students, X equals 20, and there's 3 female students, that gives us a total of 23 students because we add them together. Okay, we could also do X is equal to, let's say 10, and Y is equal to, then it would have to be 13 because 10 plus 13 gives us 23. Now we can't say that X is 4 and Y is 2 because that equals 6, and there's 23 students in the class. So we know that these are possible solutions. We don't have our exact solution, but if we're told one of the values, we can find the other one as well. So that would be a couple of solutions. Okay, so this is a solution to it. Now again, we know that X is number of males, so X is 20. X number of males, we know that that is 20. A second question here that we have is it says a difference between two numbers is 4. Now, difference, okay, it's very important that we understand what this word means because it can be a bit construed and sometimes we're unsure. Difference is subtracting. Okay, so difference is subtracting. Important that we recognize that. When we see difference, it means we're subtracting. It means that we're taking a number and we're subtracting a second number. Okay, we're taking a number and we're subtracting a second number. So when it says that a difference between two numbers is 4, there's very little context to this, but it's still often good to still define our variables. Okay, so what we're going to do here is we're going to define our variables, and we're going to do that this way here. Let's do that again, sorry. Okay, so x, see if we can get it up there, x is equal to the original number. Okay, we're going to call that the original number, or that's going to be the first number, and y is equal to the, we'll call it the second number. That's not very descriptive, but it'll work. We're not given a lot of description in our context, so we're going to say that these are what our two numbers are. So x is our original number, y is our second number. Now, if the difference is 4, that means that we're taking original minus our second number, and that's going to equal to 4. So our equation that we come up with is going to be x minus y is equal to 4. It's kind of a combination, but now we're subtracting. In this case here, we know that x is always going to be bigger than y, but there could be all sorts of different solutions that come out of this one. So let's take a look at a couple solutions that we could have in this case here. And now this should be, again, a fairly straightforward one to find solutions. If x is equal to 10, well, 10 minus what is 4? Well, y has to equal to 6. It's always going to be a difference of 4. If x is equal to negative 3, y has to be equal to negative 7 because it has to be 4 less. If x is equal to 3.5, y has to be equal to negative 0.5 because it is 4 less. So that's how we can kind of look up our solutions or come up with our solutions to that question. So again, another way of combining, but now we're subtracting, and difference is the big word there. So one more type of question that I want to show you, and this is where we also have something that is going to be applied to our variables. Okay, we're told here that a pizza costs $9 and a bottle of pop costs $2. Harold can spend a maximum of $60 on pizza and pop. Well, okay, what are our variables going to be? What are we looking for in our variables? It's important to recognize that what we're looking for is not cost. We're told the cost. We're usually looking for number. Okay, we're usually looking for number, and so it's important that we recognize that we're looking for number. Therefore, our variables, x is going to be the number of pizzas bought, and y is going to be the number of bottles of pop. Okay, that is what our variables are going to be. It's the number of pizzas bought. Now our solution right here is 60. 60 is not the number of pizzas bought or the number of bottles of pop bought. 60 is how much we spent. So we need to come up with an equation that represents how much we spent. Now I'm going to start off with a very basic one here. Okay, x plus y is equal to 60. This is not correct, okay, but this is what we're going to start off with here. This is number of pizzas plus number of bottles of pop that are bought does not equal to 60. It's the cost. So what we need to do is for every pizza that's been bought, we have to multiply it by 9. So every pizza we multiply by 9, and every bottle of pop we multiply by 2. So this is how we come up with a solution to this, in this case here. Okay, 9 times x, 9 times the number of pizzas, and 2 times the number of bottles of pop is going to give us our total cost. And it says that he has a maximum of $60. Oh, wait a minute. Look at this here. Let's take a look. We have a key word in our solution here. It says a maximum. It doesn't say a total of, it says a maximum. So he could actually spend less than $60. But 60 is his max. So what we're going to be doing is we're going to be changing this. There we go. Not sure why that disappeared. Okay, so that 60 is actually the maximum. We're going to put an inequality in there, and it could actually equal to 60, so we're going to put the equal sign as well. Okay, 60 is the biggest amount that we could spend. but we could spend less too. He has a maximum of $60 that he needs to spend. Okay. Once you get into grade 11, you'll start dealing with more inequalities as well. Grade 10, not quite so much, but you'll deal with more of those in grade 11, but we're getting a good start to those. All right, solutions that we could come up with. Well, there is a wide range of solutions that we could come up with. Now, we can't have decimals like the previous one because you can't buy part of a pizza or part of a bottle of pop. You got to buy the whole thing, okay, depending on, I guess, the size. So let's look here. We could buy 3 pizzas. Let's do 3. And we could, and then with that, 5 bottles of pop. Does that work? Well, let's see here. Okay, 3 times 9 is 27. 2 times 5 is 10, so that is $37. That works. Yeah, it's under 60. So that's going to work. That would be a potential solution. We could try to find the maximum possible solution as well. Okay, and that could maybe be a little more difficult unless we can really visualize it. But if x is equal to 6 and y is equal to 3, okay, 9 times 6 is 54. 2 times 3 is 6. Add them together, that equals 60. That's our maximum solution, or one of our maximum solutions. We could buy 6 pizzas and 3 bottles of pop, and that would equal exactly $60. So if this was an equal sign, this would be one of our solutions. Because it's a less than, we have a couple different solutions, or we have a lot of different solutions that we could come up with. So this is a combination question. We combine 2 things together into one, and when we're doing that, we're either adding 2 things together or we are subtracting 2 things. If we are given kind of a cost type thing, we often have to multiply our values by something as well. And that could also be a commission or a percentage, which we'll get into in the next section.